Okay, here we go. I think it's live now. It says I'm live, at least. Let's see. Do you guys see it?
Nope.
Yes? No?
Yep, you are in fact live.
Okay.
Oh.
I guess I will get started. So thank you for everybody for coming out today. This is the third day. It's the fourth session, I guess, because one was cut in between because of a fire alarm. But today our goal is going to be to improve the timing of our main bit loop, so that like when we're taking in the USB from the computer, and to try to decode the CRC and to be able to get actual data packets from USB. We're not going to be talking back yet, so today we're not going to be enumerating, but the goal is improve the reading, get CRCs, and hopefully decode the CRCs in line. That'll be a lot of fun. And then the last part will be to send those frames out and just print them out and see what it is the host is sending us and making sure that it lines up to what's on the wire. I guess a little bit of a recap. We're going to be working on USB for this. It's a CH32V003. It is a little 8-cent microcontroller. I don't know if you can see. Maybe that one will be clear. It's a little 8-cent microcontroller. It's the thing in the middle there. And the microcontroller has no hardware USB. But wouldn't it be cool if you could turn it into an Arduino where you just give it USB and then you can flash it with the bootloader that lives inside of a little special 1920 byte bootloader area? And what we're going to do is we're going to talk low-speed USB over GPIO, so it'll be all bit-banged USB. And yeah, that's the goal, bit-bang it. And then that way, like, other user programs will be able to do whatever they want, and we'll be able to have, like, without needing a UART, you'll be able to use it like an Arduino. Let's see. The next part is, hello everyone. Let's see here. What was the next part? So the approach that we're taking right now is that what we're going to do is we have an interrupt that gets fired. So it's an external pin change interrupt. So whenever this pin right here, D minus, goes from high to low, that's when we trigger. And we have an interrupt that gets in here, and it starts listening sometime around here is where it starts to actually like really wake up. Oh, sorry, that's keep alive in here. So it goes from high to low. Sometime in here it starts actually running. And then it runs and it looks for the end of the sync. Once it hits the end of the sync, it starts running the decode loop, and then it starts sampling each one of these bits one after another. And what it's doing is it's trying to sample into that signal and be able to see what are the wires at this current time. And as you can see, it's not actually synchronized at the moment, so we'll have to improve that. But thankfully, there had been some people who had thought about this in between. They did their homework, and that homework included a really clever thing by GDEL Jeddas. I have no idea how to say that name, but this person did some clever thinking, and they realized a way to rewrite some of the things which are longer instruction words as compressed instruction words. And using that, I'm pretty sure I can actually simplify other things as well. So thank you so much for that like little pro tip right there. So we're going to be trying to implement that. And the next part that I wanted to talk about is the CRCs. One of the things that I spent some time doing, this was my homework, was to write examples of how to do the USB CRCs. So I wrote both inline ones where it'll process one bit at a time, and it runs the CRC code right here, and it checks to make sure that the CRC output still matches. And the other one, just to point out, you don't have to do CRC that way. You can actually do CRC bytes at a time by using a table. And that's actually much, much, much faster. But in our code, we're going to have a bunch of NOPs. So instead of a bunch of NOPs, we can do CRC computation inefficiently. One other bonus point is doing it inefficiently takes much less RAM, and we want to make sure that we have as much RAM as possible available for the user application. Or we're not RAM, flash. Memory. It uses much less memory, and we want to make sure that our memory footprint is what's constrained. And so this is a situation where a lookup table is probably not the best solution. So what was the next part? We've discussed the CRC, the timings. Oh, I can't remember who it was. There was somebody else who recommended we turn on MCO, which I have not yet done. But MCO is going to allow us to watch the state, like the clock cycles of the processor, and actually count cycles to see how many things take, instead of us just trying to do it based on time. So that's going to be neat. I don't know how well that's going to work, but we should probably do that first. Then the next one I want to do is improve the timing on the ingest loop. And if all of this is successful tonight, I want to be able to try to decode CRC and get the packets into user space. So I hope that all of these things, in user space meaning like C, get the packets into C code. So if all this goes well, that'll be the evening tonight. MCO stands for main clock out, I think. Actually, we should find out. Let's see. It stands for MCO. It just says clock output. MCO clock output. Clock output. Microcontroller clock output. Not master clock output. So that's fair. So yeah, we should go give that a shot. I guess that's what I should do first, just so that we can actually understand the timing here. And yes, as always, the cat cam is up. So there is Friday. Good boy, Friday. Good boy. Let's go add MCO right now. So I'm going to go edit rv003usb.c. And there's a demo with MCO inside of ch32v003 fun. So if we look under the examples folder, it'll be under, where is it? I thought we had, MCO test, here it is. And so what I'm going to do is just copy and paste some of the code from here into rv003 USB, and we'll go from there. It looks like whoever that was did not use tabs, unfortunately. You do tabs most of the places here. Anyway, so that's set up. Let's see, is that right? CFGLR mode, I don't know. Maybe that's right. Oh, I see. There's different options. Sysclock signal on MCO. That's the one that we want. So we should write that into sysclock signal on, no signal. Okay, here it is, sysclock signal on MCO. Okay, let's put that in our code and see how that goes. Wait, we don't want PC4. Ooh, I'm a little bit confused here. What pin is MCO on?
Only have the one choice.
I know there's only one choice, but what is that choice? I guess, is it a choice if there's only one? I guess it is a choice, because you could choose to have it off. Where is it?
PC4.
I'm blind. Why can't I see? Oh, yeah, right there. Okay. PC4 is MCO for watching timings. Okay, let's give this a shot, and let's just actually clean it up just a little tiny bit. Okay, and let's see if the processor bricks itself when we do this, because I have literally no idea. Well, the processor didn't brick itself, so that's a good first step. And I will probe PC4. So I'm now watching PC4. The processor does not have M cycle, unfortunately. It has syscount, which is an ARM style thing. It's an ARM peripheral kind of thing. It is missing the CSR for M cycle, which is really, really sad. Also, don't worry, David, or Wilmore. I guess I just know you as Wilmore. But the no, it does not have. Oh, Friday. Why? So we're going to see if we have M clock out now. We do. Look at that. That wonderful M clock out. So that should be about 48 megahertz. And yep, it's about 48 megahertz. It's a little hot there. Let's see if it's... No, it's actually pretty hot. It's not really great. 48.278 minus 48 divided by 48. That's that's about right. That's 0.6% off, which is still within USB. Okay, it's okay for USB, but that is actually a lot off for what our goals are. Well, we'll just hope for the best. So. Let's see. One of the nice things, well, this is going to be a little difficult, but let's just give it a shot. Let's just see what our current timings are, and then we'll start making some of those changes. So I'm going to say make, I'm going to probe, I'm going to reseed. Oh, it already did it. And so what we can do is actually literally count the cycles. So this looks like it's kind of here. So this one, 2, so it's 69 a second. So I would say this is 1, 2, 3 cycles. And here it's, I'd say about 1, 2, 3 cycles. So yeah, so each one of these is about 3 cycles. Is that what we would expect? I think it is, because 3 cycles would be, we turn on the pin and we actually say the store word to turn it on. Then we store the number in the value to turn it back off. And we send the value to turn it back off. So this takes 1 cycle and this takes 2 cycles, and that adds up to 3 cycles. So we can actually count the number of cycles for things. So I can say select this area right here, and let's see, it says it's 32 cycles. So I think that is that right? Is that 1 short? I think that's 1 short. We can start actually looking at this. So I'm going to take that there and this here. Wow, actually it looks like it's right. I can't remember if we changed something to make it get there or not. I think that that's fine. I think we're good. Let's see. I gotta get out of a channel, otherwise I will forget. There we go. Okay, so MCO works here. I guess we'll just leave that on. There's really no reason not to leave it on, except it does. Let's see how much it chews up memory. It's not that bad. I think it's reasonable. We can leave it on for the time being, and maybe we'll want to turn MCO off at some point. But for right now, let's just leave it on. It's neat to actually like monitor the timing like that. Let's see here. What is chat saying? Microprocessor clock out. Suncat. MCO has, no, it does not. MCO. So for toucans, your question is for MCO. It going high and low. So this right here, this top and bottom, high, low, high, low. The high, low is 1 clock cycle. It's not high clock cycle, low clock cycle. In the demo, if you want to check out the code. Okay. Yeah, I can't remember. It was somebody in chat recommended that we use MCO to count the number of cycles, and that was a really good idea. So we're going to go do that. So the next thing I wanted to do was I wanted to modify this code in order to make it so that it would be well, faster, and also take advantage of the change that that was recommended. And we're probably also going to use something called a nested control structure, which is a little bit weird. It's like while can encapsulate a set of statements, and you can have another like control structure outside of that, like for, and then inside of that you have a while. But in assembly, you can really take advantage of some things and just cross off all those boundaries and just go to around however you feel like. And I think that we can actually do better if we do that in this situation. And it's actually only simple. It's only going to be 1 nest, so it's an idea I had. But let's get started here. So the recommendation that they had was that to go from 0, 0 turns into 1, or 1, 1 turns into 0, was to do an add I and an and I, which is really clever because right now we're doing much more than that. Let's see where that is. Oh, and then so I took that and went a little bit further with it, because what I wanted to do was to do something like that first and then OR it, and then I could also use the same thing for bit stuffing. So I'm going to go give that a shot right now. So right here, I believe, is where we're going. Thanks for the super chat, Tamias? I'm not really sure how to pronounce your name. I'm sorry. Anyway, so it was a 1,000. I'm not even sure, what is that currency? HUF. Well, thank you anyway for the tip. So what we're gonna do is I'm going to go copy and paste some of this code here, and we'll copy and paste a little bit more of it later. But right here, A2. Store the data into our accumulating register. It's from Hungary. Oh, thank you very much. SLTI set less than immediate. Guest, I'm not sure. SLTI set less than immediate. What does that do? What does SLTI do? Let's risc-v ISA specifications.
Oh, it's like a conditional move, I guess? Or, how would you say it's like the equivalent of an x86? Like a flag setting operation, essentially.
Hold on. You're actually... I gotta adjust this so I can hear you. I don't know why I can't adjust the volume. Try talking now.
Hello?
Okay, what did you say?
I said, I just said it was like an x86, like one of the flag setting instructions.
I'm actually unfamiliar with it even on x86. Is it just if something is less than an immediate, then it just puts 1 into the value instead of...
Yeah, so in x86 you have like set AL or something like that, where yeah, what you're doing is just setting the value of the flags register into something, right? Like a given bit, like the 0 flag, right? You set that as
okay.
As part of your register. So I guess it's the same thing here, where it's like you write 1 if x is less than y, otherwise write 0.
That would be really cool. I actually think that that's exactly what I want to do. It is technically exactly what I want to do. I'm worried though that because it's not there's no compressed analog for it, it might not work out. The reason that I'm worried about that is that, so one of the things I wanted to point out was I mean, maybe somebody's going to figure this out better later, but non-compressed instructions really seem to have a lot of very strange rules surrounding them with regards to how long they take. Most of the time they take 1 cycle, but a lot of the times they don't take 1 cycle. And I don't really know the rhyme or reason why non-compressed instructions take not 1 cycle. But what we should probably write here is optimization. We could use SLTI. I agree with you that we could probably do that. But for right now, let's go back and do the naive thing. So
We also have
say it again.
we also have good timing now. So
I can't hear you.
no, I'm saying we also have like cycle accurate timing now, so we could always check.
Yeah, yeah. And I think that will be fine, especially with the new technique. Before, it was like I was using 3 instructions there, and I did not know about SLTI. I would have just tried that. Anyway, so we now have ORed the bit in with the word. So now we have this word that's growing. And, well, we also have to handle the bit stuffing, so that's a little concerning. Maybe we don't want to stuff it in. Do we? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's actually okay that we would do that. Maybe we'll mess up the bit stuffing. We'll have to go play with that later. To do, what about bit stuffing? What if this happens too early? Okay. What was the other thing I noted that we have to do? So down here, the one thing I needed to do was, for the bit stuffing, hold on, give me a second. Let me think through some of this. I'm not exactly sure right now. So the problem is for bit stuffing, what we actually want to do is like skip the next bit. So like the next bit after a bit stuff. A bit stuff is what happens. So one of the problems with USB is, let's go re-enable this, is that anytime the value doesn't change, it's a 1. And so for USB, if you have a run of, this is only 3 in a row, but if you have a run of 6 ones in a row, then it forces the next one to be a 0 and you don't record that 0. So let's try to think through that. So first, we see our bit. Say it's like a 6th one right now. Then if it's a 6th one, we do actually want to record, we want to record that the 1 happened. And if, handle bit stuff. What do I do here? Okay, so handle bit stuff skips the current bit, which is not the correct behavior. We want to skip the next bit. Oh gosh, this is already complicated. I was hoping we would breeze through this part.
So wait, is your read loop unrolled here, or
Say it again.
Okay, so your main loop here is not unrolled, or is it?
Give me a second. If 0.
Yeah, sure.
Sorry, ask what you were asking again.
Yeah, sorry. No, I was just confused. Whether your like main read loop here, whether there's some type of unrolling happening, or whether this is like reading 1 bit at a time and then branching.
It's reading 1 bit at a time. Like
Okay,
it's
gotcha.
going to be extremely not nested. It will be able to be read clearly as steps and then jump around. And I did decide to abandon C. So we're going to only write the bit reading in assembly. Sorry, this is an answer to somebody who asked in chat. Bit reading in assembly. And then we're going to do all the processing in C land. So as soon as timing doesn't matter, we're going to go back to C. Just FYI. But yeah, let me try to think through this. So the idea is the bit comes in, say it's the 7th 1 bit. This is going to happen. What we really want to do is still read in the next bit and do all of the wacky XOR stuff. But ignore that the bit ever came in, basically.
I mean,
We
one
just
way you could
clone
do
this.
Say what?
So, I mean, one way you could do this if you want to, save a little bit of space, you could have some type of mask that you set conditionally, right? And then every time you read in a bit, you AND with the mask, and then you set the mask to 0 if the previous bit, if you know that you detected a bit stuff, and then you can set it back to 1 afterwards, if that makes sense. And then you don't need like a second.
I know that I can do that, but it would be nice if this could just jump back up in the code, because we're not doing anything up here. This is all just free real estate. So like by processing and then, oh, we have to handle a bit stuff, oh, just jump back here and keep executing. That's probably a better use of our resources. Like the whole point is like, well, I mean, the other part about all of this is we're still going to also have to have enough time in order to we're going to have enough time to handle the CRC stuff. Toucans, I absolutely could just record all the bits and then ignore them later. But my goal is to make it so that we do all of the processing while we're getting the data so that we can turn the bus around really, really fast. The issue is, so it is absolutely easier to do it in post. Maybe I should just leave this up here in case the chat gets like disappeared like it sometimes does. It's going pretty good. But the thing is, if I do it in line, then we don't have to go back later and fix it up. So, maybe I'll just handle the bit stuffing stuff later and down here and we'll figure it out. Handle bit stuff. So down here we want to wait a little bit, then read another byte and make sure everything is well before heading back into the main loop. XXX to do. Okay. So otherwise, let's do the bit process. Okay, I think that that'll be fine. in the event of a BitStuff event, we do want to do a little bit of work here. My other question is, I'm super curious how much free time we have. So let's actually answer that question first, because that's an interesting thing just to know. So let's go see. Hello? Hello? Anyone home? Oh, it didn't compile. Handle.
I'm guessing you have duplicate definition of handle bit stuff.
Yeah.
Yeah.
Ooh, 131. Oh, c.or. Okay, there we go. Look at that. I don't really care that the system timed out. So let's see. How fast are we? How fast are we going here? Well, I will definitely tell you that is way faster than I was anticipating. So something might just be wrong. This says 28 cycles. So we have 4 free cycles now. That's a lot more than I was expecting. Let's make sure it's right. So what it should be doing is it should be recording 1, 2, 3, 4, 5, 6, 7 X. And so X is oh, why is it doing that? I'm gonna just put some debug code here to tell me that something like the bit stuffer got hit. Oh, the bit stuffer is getting hit a lot. Okay, so something is not right here. Because these bits are going high and low all the time, the expectation is that this should not be hitting the bit stuffer. This diddle-it is the bit stuffer getting hit. So why is that getting hit? So the idea should be, let's see here. Right here, A0 should be 1 if the input is 1 and 0 if the input is 0. And so -1 should be F if it's 0, or if it's 1, it should be 0. So we OR it, we AND it, so it can't ever be over 7. We subtract 1, so it's -1, and then
Can A0
say it again.
Can A0 only be 0 or 1?
I believe it can because of this line right here. So c.andi A01 is.
Oh, I missed this.
Yeah.
Okay.
So we changed some of this around based on the findings or the thoughts that Zari had. Sorry, I'm really butchering that.
What bit stuffing is, by the way.
Say it again.
Timenti is asking what bit stuffing is.
Oh, okay. To reiterate, for bit stuffing, if you have a run of several ones in a row, then you like the line would be high for too long, and it wouldn't be an AC line. So the idea is they want to get rid of any kind of DC offsets. And so if you have 6 ones in a row, the 7th bit has to be a 0. It'll flip, but you don't record that 0. That 0 is like a fictional 0. But what we should see is we should not see the bit stuffing getting triggered here. It should not be getting triggered there. Okay.
maybe A0 is getting set to 0 when it shouldn't be. Or wait,
1.
actually,
It would be being set to 1.
Yeah.
Okay, so let's go back through this. So here,
Yeah,
it should be either 0, 0 or 1, 1. If we add 1, it's 1, 0 or 1, 0, 0. If we AND it, yeah, that should be right. Let's, just for the sake of tests, do that, and then just Venti, just FYI, the 0, it is not treated as a 1. It is just ignored from the bit stream altogether. So instead of transferring data over USB at 1.5 megabits a second, you actually just transfer a little bit less. I'm curious what happens with the bit stuffer if we just every single frame just... Oh, they're all zeros. It's all 0. All of the bits are 0. Why are all of the bits 0? That's not good. Maybe we've been doing something wrong the whole time and I just never even knew it.
Are you sure that Zord trickery is correct?
No, but let's work through it. So... Oh, it's not right. Well, it is right. Sort of. We need one extra... What?
Sorry, what are you trying to accomplish with it, I guess?
What I'm trying to accomplish is I want to get the XOR of the last frame with this frame. So then it would be... And I also want to get the value out. Like, is it... Like, sorry, and I want... Sorry, last frame with this frame. I want to keep the value of last frame. So what I do is I get this, I XOR them together to get the answer, and then I XOR this with the last frame in order to save this frame. So I think that's right. But what I think is going on is USB dmask, it's not 1, 1 and 1, 0, it's not 0, 0 and 1, 1. It's 0, 0 and 1, 1 shifted up to where the bits actually live on the USB line. So we're going to have to shift everything down. And we're going to have to shift it down by... that. Okay, so we're going to shift it down. Maybe this will work. Let's see if this works. So what we're getting is 0, 1, oh no, oh no. It's close though. Well, we're also still not lined up, so maybe that... I don't know. Maybe this is right, because it's all zeros here, and it... Okay, so maybe that was the bug. Now I'm also curious where we are timing-wise. 33, so we're 1 over now. Wait, how did we go 1 over? Oh, because the alignment is now broken. Well, I'll just add a c.nop right here. Because who knows, we might find another thing we have to do. Should be back to fast with this. $33, so no, it's still slow. Well, I got knocked off track pretty quick there. I'm not sure why that's 33 cycles now. It is 33 cycles, though. Let's just comment it out and see. Oh, I see. Well, hey, Kevin. Oh, this is also wrong. Yeah, okay, we're gonna have to do some extra work. Darn.
Could your debug blips be taking up the...
Yeah, the debug blips take a while. They should only take 6 cycles, though. Let's just try SLTI and see how it goes. Wait. And what would the equivalent be? It would be, if it's less than 1, that, right? Okay, so that works too. The SLTI solution works. Let's see, is it actually fast? "31 cycles." Yeah, SLTI is faster. I guess we'll just deal with it. Okay, let's also make sure it's the right value. So here, anytime it's a 1, we trigger... Yes, anytime it's a 1, I think, is when we trigger the bit stuff. Is that how we wrote it? No, anytime it's a 0. Oh, here, it's because it's inverted. Okay, so yeah, that is right. Okay. Let's also just play a little trick right here and make sure that that's correct as well. Yeah, okay, so that's fine. So this is correct. The SLTI does work. So Yeah, so that's fine. Unfortunately, it's in a really bad place. Okay, let's try that. $30, excellent, yay! Oh wait, no, 31, what? I'm not sure. What is that actually? Am I doing this wrong? Is it rising or falling? It's falling. Okay, so it's only 30 cycles, so we still have 2 free cycles. Okay. Warning, 32-bit opcode here. Zero equals 0 if 0-bit. A0 equals 1 if 1-bit. Okay. We OR in A2. And A1. No, we can't use A1 for this. So what are we... We should probably write down what all of the registers mean. Okay, so A0 equals temporary slash current bit value. A1 is last frame's GPIO values. A2 is the running word. A3, I think A3 is free. We're not using A3 yet. A4. Not using A4. Oh wait, no, we are using A4. Temp. Free. And A5 is the GPIO offset. And what is S0? S0 is bit stuffing place. And S1 is... Oh, S1 was the number of bits I was going to use for the word. Okay. So we do need to actually maintain that. So this actually shouldn't be A1, it should be S1, and we should be c.add_i S1 1. So that like every 8 bytes we will, or -1, we will reset that. Oh. There we go. So it'll go 76543210, 76543210, 76543210. Okay. Let's see how this fares. Not well. What am I doing wrong? Something is going wrong here. Really, really wrong. Should we get out the debugger at this point? Can we?
Could that be an add-I, not even done for the negative form then?
Say it out loud again.
Should that be an add-I? Oh, that is an add-I. I can't read.
Where?
Yeah, I just can't read.
Sure. Let's get out the debugger. I have no idea if this is going to work. So if I put a breakpoint here. No! VS Code, come on. Why? Okay, well, there's another path. Can we do this? Can we say B RVO3 USP .s line 150? Okay. Target remote local host 2222. Is it 2222? I guess we'll find out. No. There's some way to do this, right? Like, what is the... How do I say run?
What do you mean, like start the program? Should just be R?
Yeah, but it's not working.
Huh.
Oh, it's like GDB multi-arch. Aha! Check that out. Oh, we do have to like actually restart it though. Run is not working. I don't think run works. But there's like a special command to like reset it.
I get, well, okay, that makes sense actually because it's remote, yeah.
What was it? There is a command to like reset it. I just can't remember what it is.
According to GDB docs, there's like checkpoint and restart, but
Requires argument checkpoint ID to restart. Can we do that? Does that work? Can I just say, like, go to main?
Your guess is genuinely as good as mine.
Oh, it's rv03 usb.c. So what was it called again? It was restart 3? No checkpoint ID
So-
3. Hmm?
Yeah, you need a checkpoint
Random
ID.
stack
so-
open page
What?
says monitor reset alt.
Yeah, so
Maybe it's A. Maybe we want A.
yeah, and for the restarting thing, presumably you need to make an actual checkpoint, but that also apparently makes forks, so that doesn't seem like it. But,
So B. Let's try bag.
actually, yeah, Stack Overflow again also says add something to your GDB init file, which apparently lets you just use the run command. Okay, what?
Okay, well, it worked. I'm not really sure why. I told it to halt on boot and then I rebooted it. But anyway, info regs, is that what it is? Registers? Aha. It's funny. It thinks it has so many registers, and it absolutely does not. Okay. So A0 is 1. That's... Okay, so if A0 is 1, let's step. Then or S0 A0. Can I do that? Yes. So now A0 is 0, which is right. S0 is 7. And if we OR that, it's probably going to do nothing. So step. Yeah, it's still 7. And then we're going to add. So it should be 6 after this. Step. And that'll be info S0. Oh.
You can use display on the registers to have it always display.
How do you do that?
Some registers act.
How do you do that?
Just a second. It's display, and I always put /li, and I believe that makes it a the -li. I think changes the formatting, and then you can do
Oh, I missed typing
$.
display. What do I do?
Here, let me put it in chat.
Oh, these are not variables. They're registers, so I think they're special. Oh, $?
Yeah.
No, that shows the memory address at 0. So now it's just going to keep displaying the memory address at 0.
Okay. I know there's a way to get it to show you registers, but
This feels like it's more annoying than it's worth right now.
yeah.
We'll worry about that later. Now that we know we can GDB, like, that's fine. I'm gonna go tuck that away over here. Okay, so over
I
here.
also like the TUI a little bit better. I think it's a little bit nicer to use.
Say what?
The TUI, which is it's like the n versus based GDB.
I really need to turn you up. I can't.
Here, I can. The TUI instead of the GUI. Maybe do layout ASM.
Oh, is that a... Okay, well, let's try that. And so we want to say B RV03 USB.S150 C.
People in chat are giving us help from GDB runs.
Oh.
So the guest 73 says try layout next in GDB. And then NB 59,000 said X-I is for instruction, or you can do X and then $PC to show you. I believe that's to show the...
No, that's still going to print out the memory address. I mean, I guess it does show you technically, because it's right here. X or A0 is 1.
I guess, yeah, you could also give the TY a shot.
Could also have what?
You could give the TY a shot.
This is the TUI right now.
Oh, okay.
There's a way to make it show you the registers and their contents in that view. I'm not a wizard at it.
Control X, Control A. What? No, okay. GDB, please.
What is X/I though?
That probably disassembles the instruction, like when you're displaying it. So X/ I think is the GDB like formatting thing. So presumably it's telling it to read it's just telling it to display the next like instruction or so. There's other ones like X/something A, I think, something like that.
What I really just want to view is just see the registers, so... I don't think X is for registers. I think X is for memory addresses.
X is just examine, and then you have to give it format options.
What if I say print $A0?
It's just print, yeah.
Okay, yeah, no, you're right. Sorry, it is for it.
Okay.
No, I like.
It's print and then the $sign gives you the register. It lets you access them.
Oh, weird.
Also,
Oh, that doesn't look right. That's not right at all. This should be S0. Okay. Well, we'll leave this up. I'm going to just do... Yeah, okay, that's nice to have it both ways. I could have spent a while more trying to figure that out if I didn't step through it in the debugger and see, like, oh, this is obviously wrong. Also, it'd be really nice if I could capture Friday. Why are you a little futz?
you might be able to do layout registers, and then it might show you the register view. As well. but I'm not sure. I think somebody gives it. I think info registers works. It's just the
Info regs did work brainstorm. Yeah. Oh, sorry. Yeah, you're talking. Yeah, you guys are allowed to have conversations with people in the chat. I forgot about that. Absolutely. Go talk.
yeah. It works. I think it displays it in line versus I think if you do layout reg, it sets it in that top window. Yeah.
I didn't remove the halt, but I did reflash it since, so it doesn't even...
Yeah, guess that was 3 cents for the GDB user group. Yeah, so Guest 73 says one of the layouts is assembly with registers. And you can cycle through the different layouts with layout next. Okay, that's good to know. 30. Golai 42. I hopefully
142?
mispronounced that. Yeah. It says to view registers you use IR-reg, short for info registers reg. So I think reg is that the dollar from the register name. So that yeah.
According to... Oh,
Well, okay, but I kind of want it, like, on the side or something.
let's see.
It's probably not worth it.
Layout regs has a window showing up to date.
Okay, I'll try it.
Yeah.
I'll try it.
Okay, yeah. So the other person's right. If you do like layout next a bunch of times, eventually you get it.
Layout what?
Layout next.
Oh, I'll be darned. Oh no, but they're all the regs I don't care about. No, give me more regs.
Maybe you need... Wait. It's just resolution at that point, if you're missing a register or two.
Oh, wait. Oh, I see. They're written... Oh, no, this is all the regs I care about.
Yeah, you can scroll as well. Which is quite nifty.
Well, I don't need to right now, because okay. I will remember
Yeah.
this for the future, though. This is nice.
I like the 2E. It's better than just the basic command line.
That is a very low...
True.
Okay, anyway. Thanks, I love scotch. Goodbye, system. 5:40 a.m. Oh, boy. Anyway, okay. Let's see here. So let's just go think through this
I do have to
again.
get up at 5 tomorrow, so I am probably going to go here. So, yeah, this is fun.
right.
Thanks for letting me join on the voice call. So, bye.
Okay, bye, Sam.
See ya. What is USB demask?
Demask is both pins together.
Okay, no, I meant like the actual value. I'm looking at the GitHub repository right now. I don't think you pushed the header file up that you used.
Did I not? I can.
Yeah, if you could, that'd be great, because I'm trying to sort of think through how you might be able to get rid of either the
Okay. It's now on.
SGLI or the.
It's been pushed.
Awesome, thanks.
Oh boy. Okay, so here it is, but no response. What is going on here? Why is this breaking so badly? What if we just don't do work inside of there? Does that make it better? Yes. Why is writing to T2 crashy? Let's try this. So that's fine. But if we advance T2, oh, store word. Oh, that was right, because I was going to do 32 bits at a time. Let's just do store byte. That's just easier. Okay, so that's fine. Oh, the issue is that I was doing an unaligned write, which, okay, fine. If it crashes, whatever. Okay, let's...
Ah, damn, I should have got that, yeah.
Say what?
I should have caught that, I'm saying, yeah. No. risc-v assembly.
32, so we're still in time. Okay, so just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, end of byte. Okay, so this should still all be aligned. And then, so now we have to figure out, well, we really have to figure out two more things. One is we have to figure out, CRCs. We have to figure out the bit stuffing stuff. And we also want to be able to abort. So like if we get a message from the host that's like bigger than our buffer, we want to be able to abort off of that. So It's annoying we're not going to be able to have our debug stuff with us, but... S1, we're using T0. We're not using T0. Or we could theoretically use T0 for this count. We're using T2. What registers do we have available? So these are already being used. The E standard, that's what I'm after. Are you kidding me? You don't list out the registers. So we have these registers as part of RV on our processor. So we do have T0, T1, T2. We don't really care if we mess up GP or TP. Sure, let's just use those. What I'm going to do is use those to store these. So we don't have to set those every time. Ooh, is that slow? What is going on here? Oh, 30. Okay, so yeah, we saved 2 more cycles. Or 1 more? Ah, whatever. Can we do something to speed this up, I wonder? Yep. Hi, Colcago. Colcago? Hi. So, I still want to have debug blips, but maybe we can do something clever. I don't know, maybe this is fine. Thanks for the, the additional money. I love scotch. Oh yeah, we are definitely scooting along here. Okay, I'll figure out the bit counting or bit stuffing stuff later. I have a feeling that's gonna actually be just jumping back a ways. Somewhere up here. Sure, let's try to do the CRC stuff now as well. A4, that's just temporary, right? Oh, it's not even in use anymore. Free. Okay, so let's go look at the CRC examples. And, oh, there's a little bit of a tricky thing here. So what we really want to do is we want to read the first byte, that word that's out front. Then depending on its value, we choose whether we're doing CRC 5 or CRC 16. And then what we do is we set the value to 0. So we have to set the polynomial differently. So we have to have both the poly and both the polynomial and the running CRC value. So really, I think I want to flip this logic upside down. But we still have to do the bit stuffing stuff. Ah. This is so painful. Because we want to do recording the byte and we want to do the bit stuffing at the same time. But not really. We want to record the byte if we have to record it. We also want to handle bit stuffing. I'm just going to write the bit stuffing stuff down here. So really what we should have down here so here if A0 is, and what are we looking for? It had better be is a 0 or is a 1, then that's bad. And let's just go to abort. So C dot BR or B E N E Z, and we're going to just abort out. Otherwise, we just keep going. We don't have to handle bit stuff because it's got to be 1. We jump up back to bit process. Okay, so that's fine. The CRC, I think, ignores stuffed bits. So the CRC stuff can go here. Let's not worry about, well, I guess we have A3 and A4.
Why are you doing the bitwise and of S1 up there?
Where? What line?
143.
Oh. S1 could be really, really big. Like when it loops below 0.
Yeah, but if it loops below 0, then is that will that work? That's a good question. Okay, yeah, never mind. That should work. But I'm just thinking because that might cause problems, maybe. No, never mind. That should be fine.
Okay.
Sorry, I'm just sort of thinking because I remember having some problem like this with signed modules.
There is actually something else we could do here, which is we could store the amount of bits that we're able to store left in S1, and we could just not do a compressed instruction here. But I don't want to destroy A0. I want to have another temporary value yet. Surely there's another... There's got to be some way we can do this, so... I wish there was like a branch if mask is 0. Or is non-zero. Oh no, I messed up. Thanks, Wilsey. I'm gonna push this up to the web so you guys can see it. And we can talk through it. Yeah, check for the link down in the description to look at the code real time.
In theory, you could also only reset S1 in the fail branch, right? Like when it's equal to 0. Right, so inside the not end of byte, and that should save you some time.
Yeah. But the one nice thing about this as it is, this will take exactly the same amount of time to operate every single time no matter what.
Ooh. Is the store instruction there not?
The what? Store byte is two cycles. 2 cycles plus 1 cycle.
You're doing that at the end of the byte though, right? So I mean that's still...
This chunk of code here takes exactly 4 cycles.
Yeah, no, what I meant was more oh, okay, so you want that to have like an exact deterministic period of time, and
yes.
Moving that down would...
Yes.
Okay. Gotcha.
Is T1 free? Yeah, let's just try this. I don't know if this is gonna work, but I'm gonna say and I T1 S1 7 T1. If it's not equal to 0, then we branch. Otherwise, we go in, and then down below, I can say branch or C dot B EQs or BNEZ S1 that. So that's a free check there. What is Friday doing? Friday's probably over there looking at it. Oh, the bird? No, he's inside. Give me a second here. Up all of our timing, but let's just see what happens. Ooh. Oh, C. Yeah. I know we can't do that. Duh. Oh no, we can do that. Actually, we should also do that down below. And up here, we should say... Friday, they say hello. Friday. Oh, nope, he just wants to do his own thing. Oh, that's weird. Oh, I think this is receiving exactly 1 byte and then bad things are happening.
Oh, well, wait. I mean, it might be going into the bitbang loop then, maybe?
I need, yeah, it's
Or
exactly,
not loop, like
it's going right past here. Oh, well, that's a little weird still. Oh, because I only said that it can write 7 bytes. Okay. How big do we want to make the USB buffer? Let's see. I don't know, 16 bytes I think would handle every possible contingency. So S1 is what we're going to say is going to be the size of everything. So number of bits. Oh, actually, we would do better to store that in T1. And it would be, the number of bits that we'll be storing is USB buffer size times 8. And so let's see, T1. Oh, we should write down T1. Number of bits in buffer remaining. Okay, so, and actually what we want to do is it's and I S1 T1 and then C S1 add I. Okay, actually I just realized that's a wash. That doesn't apply to anything at all. Okay, undo. S1. Okay, so let's make sure the logic here is good. So the first one, it's going to be 8, 7. 7 is viable. Right. So next one is going to be 6, 5, 4, 3, 2, 1. And then the next one is going to be 0. That looks like that works. Okay. Because that's 8 and it all adds together correctly. Oh. So let's see here. The next bit that we're going to be doing is, so I think that our logic to save data is fine. We can do CRC stuff here. We will want to handle the bit shifting stuff. Let's make sure that the code doesn't explode still. We should be able to like record data into a byte. Oh, come on, just record. You know what? Whatever. Good enough. I got some data. Okay. So it looks like it's chugging along. It's recording a whole byte and it's stopping. Okay, so let's see. How much time are we using? Are we running over? 30 cycles. Okay, so we still have 2 cycles to do a CRC. Can we do the CRC? Probably not, but let's find out. It would be so cool to be able to keep the debug stuff in. Cole Kago, I don't think we'll be making something like an i9 at home. We're still making some very simple ICs at home. Okay. Oh, hey, MM cool is cool. I haven't seen you in forever. It's good to see that you out on the live stream. Anyway, CRCs. What registers do we have free still? We're not using A4 still? I guess we're not using A4. Okay, so both A3 and A4 are still free. We have to do the weird thing I mentioned with the very first byte has to do something clever. Which kind of ruins a lot of the other things I was hoping to accomplish. Sure. Let's just abandon what I was trying to do there, and we'll just do... this. For when we're saving off the byte, we're just going to skip the debug blip. I still want to have the debug blip for all normal bytes, so we still have to find some way to try to accomplish that in time.
Oh, by the way, just random thing. I'm wondering whether you can turn that jump into like a C.J.
Here? Maybe.
Any of them.
Well, it looks like the compiler automatically will do it for us if it can.
Oh, yeah.
Annoyingly, though. I will say annoyingly. I wish that I could tell it which way I want it to go, but...
I mean, you could explicitly either turn compressed instructions off, which would be bad, or I think there's a
I'm
no
listening.
relax. Hold on, let me check.
If you know the key to making it not do compressed instructions, I would be very interested.
Yeah, give M no relax a shot.
Say it again. Give what?
I can send in chat if you'd like. Dash M no. Dash relax.
Oh, no, I want the relax. Sorry. I want
Oh,
that
no,
for
that's
the
fine.
rest of the C code, and we're doing FLTO, so we have to do that.
Yeah. No, that's fine. I mean, alternatively, you could assemble all this as an entirely separate object file and then link it in later.
I could. If I have to, we will, but so far, I think that we can just deal with it, and like whenever things don't quite line up, we can just like maybe add a NOP or switch things around a little bit to make it all line up. I'm gonna write the CRC code now, though. So A3
Oh, actually, there seems to be an assembler option for this. Try this.
Oh, that's interesting then.
And
We
then
should-
make sure, you know, everything works with obj dump and such.
Yes, let's try that right now. What I'm gonna do is I'm gonna have a J down here. Okay, let's give this a shot. Oh, I gotta fix that. Okay. No. See the J1F0? It totally encoded it as a compressed instruction.
Ooh, that's not good.
Sorry.
Okay.
No dice.
Unfortunate. Let me scramble around a bit more, see if I can find something.
Okay. Okay, and so what I'm going to do is I'm going to store A3 as the running CRC and A4 as the polynomial. So the way we do that is I have the CRC examples here. So I'm going to just copy paste this in the C code, and I'm going to go rewrite it. So 3 is running polynomial, and A4 is going to be not running polynomial, but why am I blanking? Oh, it's not the running CRC. A4 is the polynomial. So what we're gonna do is A0 is gonna be 1. So, oh no, we have to do XOR. Ugh, this is gonna be so many instructions. And we need a temporary value. Oh my gosh. Sure, whatever.
Guest 73 has an interesting idea, which is to, for the jump instructions, disable
Yeah, I know.
and do
I
push
know. If we decide we really want to do that, we'll do that. That's a good point, guess 73. Okay, so we'll have that in our back pocket if we need it. So So what we want to do is we want to say if it's true. So set less than immediate t0 1. So if it's 0, then it becomes 1. Branch not equal to 0. So if it's 0, it becomes 1. Okay, yeah, I think this is right. Oh. How in the world does this work? I'm so surprised. And actually, the polynomial really does not deserve to have its own thing. We'll just keep that special. We'll go shove the polynomial somewhere else. Let's see here. We're gonna do... We'll just put it in the thread pointer since we're not going to use that. Or RA. No, we don't want to blow up RA. So the way this works is... I think that works. Does it? That's a lot of instructions we're burning on this, though.
If you want it to be constant time, you could avoid the branch by using an AND instruction, and then setting, like, you already have an AND instruction there, I guess. So you could AND, no, that wouldn't work because you would need to extend the, like, some type of mask out.
Which we can do that, by the way. Remember the whole trick of where you just subtract back around 0.
Yeah, I mean, yeah, that would work. So I guess you could do that, and then you
I mean, it's just my
could-
concern is this turns into 4 cycles no matter what. 4, 5, 6, 7. So polynomial is going to be 7 cycles. And MM is cool. I don't want to use a minimalist thing, but every time I try to program, I end up like just having to abandon all of the crazier stuff. So I just end up in this world. We might have to abandon CRC for now in line. I mean, like, what happens if we just do this naively? Let's just see. Oh no. 166. What am I doing wrong? SRLI. Oh. A3. Oh, it's A31. And illegal operands T1. Oh, because you can't use the compressed instruction for the. Ooh, ew, 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 ew. Oh, whatever. XOR A3, A3, T0. Hey, okay, so reading. I'm not sure why we didn't get a bit until here. 1, 2, 3, 4, 5, 6, 7. Uh-oh, my cat is doing something. What are you up to? Where are you? How did you get up there? Friday. This cat. He somehow got in the kitchen cupboard. He shouldn't be there. Can't believe he lets me do this. Anyway. So we read a byte, we read another byte, 1, 2, 3, 4, and then we're at the end. That's not right. Really what this should be, let's do a USB protocol decode. Maybe that is right, because the sync ends here. 1 byte. Oh yeah, maybe that's true. One, two. I'm not sure why we don't get the blip on the first bit. We should totally have a blip on the first bit. Oh, but I remember what the problem is. The problem is we're taking way too long. That's why that's not working. Yeah, 40 cycles. We are taking 40 cycles. That is not acceptable. Mike Minestrone, if you want, I've actually made all of the USB CRC stuff available for all variations. So if you're curious on this project, I have CRC examples, and the CRC examples both show how to do it bit at a time, and they also generate the appropriate tables, so you can do byte at a time USB CRC for both 5 and 16 bit CRCs. That's just if you have anybody has any trouble ever working on CRCs for USB, just go do this. And 2 cans. No, 1F means 1 forward. So you can say 1 here, and you can say either like 1F to jump forward, or you could say like 1B to jump back. And that way you can have numbered like labels, but you can like nest them, and you can do all sorts of weird stuff like that, and like reuse them without it having to like go be messy. Like you don't have to create unique label names and stuff like that. So 32 or 40, 39, 38, 37, 36. We'd still 4 cycles short for our whole thing here. Oh, by the way, the CRC code also, I explain where the polynomials come from. So you can actually use this code to generate any CRC polynomials you want, and you can use it to however you'd need. So bit at a time or table, and it'll do any polynomials. So you can use CRC32, any of the CRC16s. If you use this code, it'll just let you be able to use any of them. One of the other fun parts that I'm going to be doing is you can also like play with it, and you can choose to have arbitrary start values, so that like say you want to make it so when you're done you don't have to compare the output. You can just be like, oh, you know, it's 0, therefore the CRC is good. You can also do that, but this lets you play with those things. So like if I go run that USB CRC examples make, if I run this, what it does is it creates the table, and it validates that like the CRCs match the example data, and then it runs the table. So like using this table, you can then do fairly fast CRCs. Honestly, at this point, I'm thinking maybe that's just the right answer. Do byte at a time, or we could do it in post. I really don't want to do it in post, though. I really want to try to do it in line. Although, you know, we actually save cycles here. So inside, First of all, I do want to understand why the first bit is getting dropped. That's a little weird. I was just thinking I could do the CRC code. The problem is the CRC code requires a load from a load from a table, and it requires a fairly large table, so I really don't want that. This is really hard to do live. I'm really struggling right now to like not want to just like close it down and figure it out and then come back. This is the right kind of structure of what we want to do for our loop, but it's going to take like a lot of massaging to get this to actually work right. I am super curious what happens if we make A4 the polynomial. Or if we use A4 instead of T1. Oh, but that's not right. Oh, yeah, A4 instead of T1, yes. There's really no good way to do this. And Colcago, yes, this is for cyclic redundancy checks. I'm really struggling here. Why is this so hard to get?
Main problem is speed.
Say it again.
The main problem is just cycle times right now.
Yeah.
Trying to think of how you could maybe slightly reduce the time spent in the bit bang check or the bit stuffing check, but I don't think you can.
Yeah, it feels like this should be way faster. Like there's got to be a fast way to do that. Like, what am I missing? We are pretty close. Let's check our cycles. 40. Still the same. I mean, let's see. If we don't do the CRC code, how fast does that make the outer loop?
I mean, there might also be something in the.
Say what?
And there might also be something like outside of the loop that's optimizable here.
"30 cycles." Yeah. Thanks, Lori. Luri, L-U-R-I. Luri Castro? Thank you. We could do something even weirder, too. We could... Oh, this is weird, but... Maybe this is right. So here's what I'm thinking. We could actually structure our code so that it fills up a byte, and then it jumps down, and then it reads the next bit, and then it executes different code for when it's going to like write the byte out. That doesn't involve like the jump or anything else. And then after that, I could do the CRC on the byte. I don't know if I want to do that though. Also, I'm still not sure why the very first time in it's getting triggered. Maybe it's... Oh, because we also will need to set the CRC after the first byte anyway. Ah, this is so tight. Okay. I thought this was going to be a walk in the park after that tricky stuff earlier online. Or SLTI, I guess, was kind of some of the tricky stuff. Urge to do some off-stream mining. What do you mean? Guess 73. What are you referring to? The CRC macro doesn't have a -1 in it. Oh, mine off screen. Okay, that makes sense now. Mining for solutions is what I'm doing. Maybe there is a way to do this. So if we XOR, let's bring the C code back so we can compare it. Also, actually, let's... make sure that the C code still works. Looks like it still works. Ooh, actually we could do something clever. If you XOR with 0, wait, right?
Yeah. If you XOR with 0, it's no up, right? So what you could do is, and I was talking about this before, what you could do is sort of have it, you do the -1 magic, right, where you wrap around, and then you do a bitwise AND. But I mean, that's extra instructions, right? I mean, the question is the branch more expensive or is the mask more expensive?
We might be able to do it elsewhere in the chain where that isn't true.
Maybe.
So what we actually want to do here is do XOR is CRC 5 poly. Oh my gosh, this is horrific. I'm going to write out another example with the horrific bit version of this. Okay, so the horrific version will be polyxor, and polyxor is going to be this mess right here. It's like, is it neg that? No, because it'll be 0. If it's 0... Oh gosh, there's got to be a fast way to do this. Why is SLTI not just make the entire word like all ones? So you're saying take this
X36.
minus 1. So now it'll be 1, 1, 1, 1, 1, 1, 1 if we want to do nothing. Then we're going to neg polyzor. Or we could or polyzor with inverse of CRC5 poly. Oh gosh, this is awful. No.
Yeah.
Oh my gosh, this is so bad.
Yeah.
Polyzor.
I very much doubt this will be any faster, if at all.
Polyzor and equals CRC5 poly. Oh my gosh. Yeah, I know that a table is faster. I might end up there. Oh my gosh. This is so evil. And CRC5 or equals polyzor. Well, that's really bad.
Okay, hold on. Yeah, could you not just take the negation of BVs or CV, CRC5 and 1? Because then you have 0 if you want to do nothing, and FFFFF if you want to do something, right? And then you...
Oh, ho, 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 ho. Clever. Okay. Oh man. Oh, if that works. I mean, it's giving the right answer with the CRC5. Wow. Wow. That is some evil code. So that's 1, 2, 3, 4, 5, 6 instructions overall. It should be 1 instruction faster. 1 clock cycle faster. Can we shave off another instruction? Oh my gosh, that would be something. I can't imagine that though. This is already so tight.
Ooh, yeah, that's a good question.
I don't think we're going to be able to shave off any more.
Yeah, I don't. Yeah.
Well, let's write it out. So XOR is, so we're going to XOR A4 is, yeah, okay. So that's the first one. And then we want to and I. And then we want to neg. And then we want to and A4 with A4 T0. Then SRLI A3 1.
We know that BV Zor CRC5 like wait, hold on. We just want the like lowest bit of that, right? Like
Yes.
Could we not also just store the lowest bit of CRC5 in some location? Maybe.
What would that bias?
But that also... yeah, that's a good question. But also, what does CRC5 start at?
It starts at 0.
Yeah. No, I mean that'll bias. That'll get rid of the and instruction if maybe. Alternatively, it pushes the and instruction somewhere else.
Because we're gonna have to. You have to do this. You have to figure out like the polysor is going to potentially change it, right? Oh,
Yeah.
you mean what is the bottom bit of CRC5 poly? What is the bottom bit of CRC5 poly?
Oh, not even CRC5 poly, but also yeah. No, I was thinking CRC5, in general.
It's a
but-
0.
Yeah, but let me think. No, yeah, that probably wouldn't save us.
Anyway, SOR A3, A3, T 0. Well, that gets rid of the jump. I'm super curious how that performs. The time to beat is 40 cycles. Let's see if we've beaten it or if things are awful.
Always the question.
What? What? Did I mistype something? Oh. It didn't compile. Apparently I don't know my words here. A4. SRLI. C.SRLI. Okay, there we go. Now compiled. Oh yeah, that's a lot more than 30 instructions. Oh, we're still at 40. We saved 0 cycles through that exercise.
Excellent.
Oh. But at least we got rid of a branch, right? Uh-huh. Isn't that something?
I'm surprised that it's actually still 40. I'm gonna be honest. Like I would have expected it to be more, genuinely, because I didn't think branches were expensive. Yeah. Where?
I'm also curious for the skip byte, the one where we're storing the data. I wonder how many cycles that is. Because that'll be 40 plus, or yeah, 40 plus X is 76. 76 minus 40 is 36 cycles. That's pretty close. But that also makes sense. Like, how in the world does the AVR stuff do the CRC so quickly?
Well, for a 5-bit CRC, you can just do a lookup table, but
I mean, for even a 16 one, the 16-bit lookup table is only 512 bytes for a CRC.
yeah, but we have like 2K bytes for the bootloader, right? So
Yes? You're saying this is a bad idea? I think it is a bad idea. Oh gosh, where is it? Seriously, I thought one of these did the CRC inline. Oh, version is smaller because Drive 18-CRC. Okay, so this is the one where the CRC happens in line. So on a 8-bit micro running at 18 megahertz, they can make it work. Surely we can make this work. So right now we're looking at what the VUSB folks did, because I'm just curious if they have any neat tricks that we can use. I wonder what SEC means. I don't know what SEC means. Rotate right. Load. How? What? What is going on here? Are you seeing this, Duck?
Yeah, can you send the link? What are they? Wait, what? This is the entire loop?
Well, there's like other stuff down here. Oh, they unroll it. They have 4 bits. Oh, that's interesting. So they save time by rolling like bit 1, bit 2, bit 3, bit 4, bit 1, bit 2, bit 3, bit 4. And that way they don't have to like they can split logic up into many places.
Do we have the space for that?
Each unroll of this loop at best is 64 bytes. So yes, we do have enough space to do it, say, twice. Easily. So we would need to have like a bit process odd and a bit process even or something.
I wonder.
If we abandon all of the compressed stuff and we just try our best, okay. So let's see here. Let's try a micro optimization. So here we're loading c.load word A0 from the register. But what if we load? Oh no. Oh yeah, so what if we like ping back and forth? So one time we load A0, the next time we load A1, and then it'll always be like the opposite in each loop. This is going to be too complicated though. I want this to be simple. It's like such a hard balance.
Do we even have a bit rotation instruction? I don't think so.
No. All we can do is bit shifting. That would be pretty cool. Like there are a lot of times where I'm like, man, I wish risc had a carry register. I think though, if I'll get as far as I can on this live stream tonight, and then I will probably finish this off stream. I don't think I want to. I feel like I'll just work so much better off stream on that one. I'm willing to push it as hard as I can though tonight. But then I want to like come next stream. I want to actually like start like sending and receiving messages like to the host PC. I might have to give up doing the CRC inline. Because, like, okay, so think about it this way, Duck. One of the things I could do is, well, never mind. I was going to say I could do byte-wise XORing, But it would mean I would have to have actually 2 tables, so I'd have to spend a whole kilobyte on the tables. I don't want to do that.
It's a 5 byte. I mean, maybe if you didn't use an 8 byte or an 8-bit lookup table, maybe like a 4-bit lookup table. And then, like, I mean, in theory, if I recall correctly, it's not that that the lookup table is tied to 8 bits, right? If I recall, I've seen implementations with like 16.
No, it is, because we have to handle both the 16-bit CRC and the 8-bit CRC.
Yeah, well, no, I meant like you don't need one for every. I think you don't need them for every single byte. I think you can split it up. Is one of them. Hold on.
You could do it like nibble at a time.
Yeah. That's what I was.
That's ugly. Oh. I mean, it is what it is. I feel like I'd rather unroll it into bit A and bit B before we did that, though.
Yeah. That seems like maybe doable with a macro. To make it not. I mean, assuming that you can like parameterize macros. I don't know whether you can do that in this type of syntax. But in theory, if you could, then maybe you could make it look nice. So, lots of duplication.
You're at 40, right? Yeah, 40. Okay, let's look up and make sure things are aligned. If they're not aligned, we'll see how much it is if we fix that. $178, so that's aligned. BC, that's aligned as well. Darn, everything's aligned. What was the option for no relax? Let's just see how fast all this runs if we disable relax. Or not no relax. Option. What was it? It was option no RVC or something.
Yeah. No dot option no RVC.
So dot option no RVC.
Yeah.
And I will. Well, actually, before we do that, let me commit this.
Oh, if we unroll the loop into like odd and even bits, we can also only do the bit stuffing loop in the odd. No, in the even loop. Yeah. No. Yes, with one of the two. God.
I don't understand how you would only do it in one of them.
If you have odd and even, or if you're talking about dispatching it on a byte level, okay, no, never
I
mind.
was hoping
If
to do
it's-
odd even. Because odd even means you can also not you can skip the branch to go back up to the top. But yeah,
Mm,
yeah, no, I think that would work. And anytime you have to bit stuff, you can just jump up, 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 and then that stuffed bit you can do extra work in.
maybe. But wait. Mm,
Oops.
Yeah, no. Right, because by odd and even, you're talking about bit offset, right?
Yes.
And bit stuffing can happen literally anywhere. Okay.
Yes.
USB protocol, please.
Come on. Say lay. Anyone home? Okay, let's count some bits. Huh? 54.
You kidding?
54?
What?
The only thing I did was convert all the compressed to uncompressed. Is compressed really that much of a performance increase?
I mean, if that's the case, then like maybe throwing more things into like maybe like even doing the CRC code as
More carefully, yeah. But there's no
Yeah.
Zors. There's no Zors that are compressed Zors. Why in the world did they not? Wait a minute. Maybe it's undocumented. Oh. Okay, we're gonna undo all this. Let's get the baseline.
I see a compressed Zor instruction in the spec.
But I don't think there's a Zor I or whatever. Or
Oh,
we don't
Zorai.
need Zor. Do we wait? Do we
yeah,
need
no, we don't need
Zorai?
Zorai.
We don't need Zorai, right?
No.
Okay, so c.zor is c.zor just an instruction? I thought it wasn't.
As far as I can tell, according to Risk, it is, but or according to this.
Nope, illegal
100.
T0. Yeah, that makes sense. Okay,
Ah.
so I do
operand,
need to
yeah.
find a place to shove A4. That's annoying. That the one place I could use a compressed Zor, I can't.
What is A3 being used for right now?
What? A3 is the running CRC.
Ah, okay. Fantastic. Wait, is there not a compressed shift left one?
What?
Or no? Oh, no. Sorry, I'm wrong. I misread SLTI. Sorry, that's on me. I read a shift left.
I wish there was like a compressed neg instruction.
Well, if there's a compressed bitwise not, I doubt there is, though. But if you really wanted to, you could do a compressed bitwise not and then add. If that exists, I don't know.
I had another random thought. What if we put the code after the bit stuffing code, and then we can blow A0 to smithereens, and we get a whole register back.
Yeah, I mean, could we do that? Like, can we do the CRC before or like after handling the bit stuff code? I guess assuming that.
Oh, but we would have to recover, because it's not... Oh, wait a minute. So if A0 is effectively inverse A0... Okay, so this is a little bit weird. Here, at this point in the code, if bit is 0, A0 is 0xFFF, otherwise 0. Okay. So at this point in the code, we can XOR A0 with A3. Oh, this is going to be a really weird one, but maybe it'll work. An awful CRC5 test. BV minus equals 1. This is like the code we have in the USB stack. So here we're XORing the whole thing. I think we can do that and we get rid of the neg.
Right, if we assume
Nope.
the minus equals 1 is free. Oh.
Nope, doesn't work. Wrong answer.
Hold on. I'm just waiting for the live stream to catch up. So okay, well, hold on. So yeah, you can't right, yeah, that's not going to work. Or well, it might if you invert the XOR as well, right? Because now where you had a 1, you had a 0, and where you had a 0, you had a 1.
Hello,
So
like
maybe
this. So polyxor is oh gosh. So it's not and equals CRC5 poly.
maybe and equals not, potentially.
Yeah, let's just at least see what happens.
Yeah, exactly.
No.
No? Okay. Oh, that's a bit stream. Hold on.
If you do the neg, then you do the not, then it works. What? I feel like, so when I do this algebra stuff, I think it should be like symmetric. Like two things cancel each other out. And then here there's 3, but somehow 3 cancels it out. What? What is going on?
Well, not x is minus x minus 1. So hold on. Bitstream. That's a good question. Why doesn't that work?
That is a really good question. Oh, if I don't neg...
It doesn't work because it's not... Polyxor is not 0 or minus 1 when we do this, right? When we do the negation, we're turning a value that... or when we're doing the end one and the negation of end one, we're turning a value, like an arbitrary value, into something that is either 0 or minus 1. Right, and so
I just tried this
So-
code. I know this is weird.
yeah,
So I did
Sure.
-1 here. I got rid of the neg. And
Yeah.
I'm tildeing here. That seems like it works. I should probably test the CRC 16 with this technique.
Oh god. I don't understand why that would work. I'm going
I
to
don't
be
understand
entirely
why that
honest
would.
with
Let's
you.
let's make sure it actually would work and that this is not like us chasing the wind.
Yeah, because that's just going to XOR with like all 1 bits in 90% of cases.
Oh yeah, it's hosed. Wait, what?
I have a suspicion that the answer is that you're getting lucky in some case. Also, you did CRC 5 poly instead of CRC 16.
Whatever. Everything's hosed now. It wasn't. It wasn't.
No,
it was broken.
Okay, straight up. Yeah. Okay. Well, that makes sense because, yeah, no, that doesn't make sense.
Oh, this is all wrong. All of this is just evil.
Yeah. No, yeah, because you're doing a bitwise not of a value that can either be only 0 or 1, right? So you'll either get -1 or -2, I think. Those are the two values you're zeroing with right now. No matter what, no polynomials involved. Um ah that bitwise and instruction. So, I mean, for now, what happens if we assume that we have a free register and we just nuke the bit banging code completely? Or the bit banging? No. Bit stuffing. And then use the compressed instructions everywhere and then see what happens. In terms of cycle count.
I mean, it's faster. It's still 40 though. We haven't made any improvements. We're still at 40.
Yeah.
We have to get to.
Wait, okay, hold on. So even with like all compressed instructions, it's still 40?
Well, all the ones that I can. I'm already using all the compressed instructions I can.
No, I'm thinking more like if we assume we have a free register somehow, like magic.
Okay.
What happens if we turn the entire CRC thing or the entire like the current CRC code into compressed instructions? What happens to the cycle count? I guess is the main question.
You can't. So the magic would be if
Well-
we can in place XOR, you can use the compressed XOR. If you
Yeah.
yeah.
No, that was the main thing is if we can if we can throw the compressor on. But if that's the only thing that we can do, we can't use the compressed end as well.
You have to do that in place. We already are using the compressed
Yeah.
and in place. Maybe we could use a better thing than neg. I still don't understand why this is the case. It's
Or what is the case?
so if BV is -1,
Yeah.
then if it's a 1, it's a 0, and if it's a 0, it's a 1 because of the and 1 here.
Yep.
So if I just not poly XOR, it should work. Or not if I
you
not
can't...
if I okay, so let's just try this. Or
Yeah.
poly XOR equals minus not poly XOR. And it's still wrong.
Let me wait for the live stream to catch up to see. But if you're doing the bitwise AND instruction and poly XOR isn't essentially 0 or, -1, then you're going to have a problem because of the bitwise AND, right? Because of the AND CRC 16 poly.
It's and 1.
Yeah, you're doing 0 and or you're doing 1 or 0 and a CRC. Like, you're losing way too much information.
Polyzor is supposed to be 0 or 1.
No, in our case, it's 0 or -1. Right.
Not here.
So it's either all zeros or all ones.
I mean,
And so what you're doing is you're changing it to 0 or 1, 1, which means that when you bitwise AND with the CRC 16 policy or poly, 31 bits of 32 bits are always going to be 0. Right? So you're either zoring in the end with only 1 or 0, which is not the same as zoring with the CRC 16 polynomial. Right.
Wait, how is this code working before? Oh, because
Also,
the
Wilmore is asking you if
neg.
you want to commit. Yep.
There has to be a fast way to do this. There's no way this can't be fast. This has to be. Well, like, then we can just go back to this, right? Like... Oh.
So- I think David's asking if you can commit the code, unless you already did. Just temporarily.
It's pushed, David. You know, David, you can just talk. You can unmute and talk on the stream.
I muted myself because I'm talking out loud, working through the problem, and I didn't want to interfere with the stream.
Okay. Why is this so tricky? Oh my gosh.
Trying to do something that does not want to be done in 5 instructions.
It does not want to
In
be
5
done.
instructions.
We're going, like, this has got to be possible, though. I'm sure the 33 people watching this really enjoy watching engineers, like, try to squeeze out that last instruction. Oh my gosh, what the heck?
How many are we short?
Well, we're okay,
1.
so we are 4 clock cycles short.
Ugh.
Well, 4 clock cycles, and we still have to get a little bit more stuff done, but we might be able to shift that around. Like, there's some other stuff we might be able to do there. But the normal default situation, we're 4 clock cycles short. Why is this... How is this defeating me? It feels like it should be easier if this is masked out all weird like that.
Well, we also don't exactly have many instructions to work with to begin with. So.
Wait a minute. BV Zor CRC 16. Yeah, as a developer, it's definitely an it's depends. We just tried changing from compressed to uncompressed instructions, and it went massively slower. But whenever I like try to like figure out how long an uncompressed instruction takes, it should be fast. Like it's like one cycle, but then in reality, it's only one cycle sometimes. But compressed instructions are almost always fast. Yes, one could say that we are working with a reduced instruction set. I see what your goal is, though. If we were able to do the not in the end. So, oh, what? Okay, so question here, Duck. If we are able to make the bit stuff check code here,
Yeah.
instead of operate on FFFF and 0, instead if it was operating on like 0 and FFFF,
Sure.
we could make it count up. Like we could make S0 count no, then that breaks this. Never mind.
Yeah. Well, I mean, you could make it count up. I mean, what you could do is you could use both. But then you'd need another temporary.
The problem isn't necessarily the temporary. It's that when you juggle things in and out, like when you can't do in-place Zors and in-place ands and in-place things,
Yep.
that's when things get sad.
Yep.
We could... No. I'm glad that you like it. How do you pronounce that name? S-A-I-D.
You do not CRC 16 billion.
I'm glad that you're having fun, because this is painful for us. This has to be possible, though, if it's masked out all Fs.
I don't even know what a 5-bit CRC looks like. I guess it's a CRC with 5 bits. Go figure.
Okay, so here's something else we could do. It might be an extra instruction, but that might be okay. You might want to look at the stream, Duck. What I think we can do is I think we can do polyzor of the normal thing, and instead of neg, we just subtract 1, and then it's functionally equivalent to neg. So we still have to and 1 and minus 1, but I think that does it, because then it'll do the whole like 0, 1 flip thing.
I guess because we're flipping it twice, right?
Yeah, exactly.
Yeah.
This might work. Okay, and it's actually it's no more expensive because it's a neg instead of an add I. Okay, let's give it a shot. Okay, so this is gonna be real weird. So Zor A0 A3 and I1. Okay, let's and I1. Oh, let's also make sure this. Let's make sure this also works with the poly 5. -1. Yeah, it works. It works. It works. Okay. And I minus 1. And we're going to do the weird thing. We're going to say add I minus 1. And we can do this on A0 so it's in place. We can use the compressed XOR. We don't have to do the neg. And A0 T0. So that's the compressed thing. But we would need... Are we using A4? Is that free? A4 is free. We could put the polynomial in there. Oh my gosh, this is horrifying. T0, so we're actually going to put that in... Well, whatever. I'll assume that that's somehow there. And then... C.Zor. And which one was the polynomial again? A4. Then we can SRLI A3 1, Zor A3, A0. They're all compressed instructions now.
Oh god.
But at this point, A0 is totally trashed.
Yeah. A0, Shmay0. It'll be fine. Maybe. Or it'll still be 40 cycles, and we can weep.
Okay, so let's go give this a shot now. It does not look good. This does not look good at all. Oh, no, 36 cycles.
Oh, okay.
Well, that's it.
Better. It
okay.
is?
Well, no,
Nice.
that's it for the outer loop now. Wow.
Okay, well. Yay.
Wow. Means we have no free time, but let's see if this lines up to the right place in all the bits. I'll be darned. It does not line up to the right place in all the bits because when we're actually like receiving a byte that no, what's going on over here? No, what?
Uh-oh.
Oh, that's right. Duh, 36 because the timing. Yeah. Okay. Yeah, we could not do our debug blip.
And then get feedback how, Wiggs? Do you mean just like not do it every bit? Or what do you mean?
Say what?
I mean, if we... Well, how would we check that, like, things are accurate?
Wait, what do you mean?
Or just, do you mean just do less debug blips? Or...
No.
Because if
I was gonna... What was I gonna do? I'm not sure what I was gonna do. I was gonna do something. Let's see if we can get some more time back or something. I don't know. We still also do have to handle bits to handle the CRC and the bit stuff. Okay, so that's gonna be fine. Okay. Wow, that is some really cursed code. If only we had like one extra cycle here. But I mean, I'm not gonna. It fits like a glove, so like I don't want to mess with it.
If you think that's cursed, I have more cursed for you.
What?
Oh no.
Do you want to overclock the processor?
No.
Okay.
This might be fine, actually. This is annoying that we have this and here, but... Wait a minute, is there anything that would be preventing us from moving the byte right out till after all of this? Because here we don't care what A0 is. It can be complete garbage. I think that we might be able to pull that off.
Alex in chat also had a really good point, which is that we like A0 or our output like register is essentially just a sliding window of bits, right? So in theory, in order to check for bit stuffing, we could just mask off the last n bits and check whether it's a specific value. Maybe. I don't know whether that would be more or less efficient.
I hope you're right. I hope you're right. We never have to corrupt A2. There's no need to corrupt A2. Oh, Alex, you're right. Yeah. Darn. Yeah, because if you have
Well, if you either get the one way to do this would be to sort of get the timing right and pretend that the stuffed zero never exists to begin with. In some way, maybe. So you could have like a second busy loop for this, just literally just for the stuffed zero.
it might be worth thinking through some of that. Sorry, both ends. The Alex's suggestion and yeah. So by the way, branches are basically free. So like this is one instruction unless you take the branch, and then it's 3 extra cycles. Or more. If you jump to an unaligned location, it's awful. I would.
Yeah, I think.
Go.
Yeah. I mean, the main. Yeah. I guess that the main advantage isn't branchless code versus branchy code at this point. It's branchless code versus compressed instructions, or not compressed instructions versus compressed instructions. So, I mean, fewer instructions is always better. But it seems like compressed instructions are ridiculously good.
Yes.
In this case.
I'm moving some of the stuff around real quick here.
Yeah.
I want to see what happens if I put if I put the CRC check and all of that before the branch here down here, the not end of byte branch, because I think here I can blow away 0 safely. Wait, oh, c.mv? Is that what it is?
See, it doesn't be working.
Let's see what this is.
Oh, I see what you're doing on stream.
38. Darn it.
Oh, is it worse?
Yeah, so that was an example where using the uncompressed instructions were faster.
I really hate that the "it depends" answer I gave, like,
I hate
15
it. Yeah,
minutes or
I don't
something
want it
ago.
to depend. Oh wait, now it's 38 as well. Because I moved this, why does moving this make it 38?
Alignment? Question mark? Unless maybe you misread it by accident the first time, which would, I doubt it, but
Okay, 36 again.
oh, okay, that's good. So maybe compressed conditional branches aren't great. I have no idea though.
Oh, wait a minute. I just noticed something.
Yeah. Oh.
What?
Oh, nothing. Nothing, sorry.
I noticed
I was
that
just confused.
it's annoying that we branch down here to do nothing to branch back up there, but we do it so that all the timing lines up. This is also annoying because that does mean we also don't have any time to check to see if we've overflowed.
So, wait a minute. Okay, wait, but not end of byte is what happens in like the majority of cases, right?
Yeah.
Do we not want to have the branch be at end of byte instead? Maybe sort of flipping the condition around could help here? Because maybe like taking a branch is expensive, if that makes sense.
There is another option we have. We could branch from here up to before the start of the function and then fall through into the function to avoid the extra branch here.
That's cursed. I mean, maybe. There is, yeah, so wait, hold on. Yeah. This feels like some code reordering could be helpful here, right? Like, if you flipped the condition so that end of byte is the thing being jumped to.
Yeah, that's what I'm doing here, and it jumps to
Yeah,
before the
yeah.
function call.
Oh yeah, okay, yeah. Sorry, stream's lagging behind again.
Okay, yeah, I think that works. Oh, this is tight. If this works out, this is really tight code. And oh my gosh, yes. Here, we're checking to see if we're out of room. So, this might be it. Let's put our debug blips back in and see. Oh, there's one cursed piece here. Okay, so we handle the CRC down here in the bit stuff. We also have to handle this mess right here. Handle next byte. Oh my gosh. This might be it. This could be the big one. This is so cursed though. So we have to have a special thing for if the bit that we're currently on is at the end of a run of ones, we still, and it lies on a byte boundary.
Oh God.
We then have to handle making sure that gets done correctly. Handle next byte is next byte and bit stuffed. Okay, this is just awful. We don't have to do any of this now though, right? Oh, I guess we...
Well, at least most of the repetitive code is macroed out, so that's always good.
I'm going to just assume that we can do something is not end of byte. Here, where we say like jump to here, because we should have enough time to go do all of that. Handle EOB, yes. Oh gosh. Oh. Oh. Okay, I think this is correct. Oh no! We do have to be really smart about this. We have to do this, and if it's the end of the first byte, we have to decide if it's CRC 16 or CRC 5.
Really quick, can we make sure that our timings are
Yeah,
on point
let's
before...
see. We've probably blown that all to smithereens at this point.
Yeah. No, I'm just I'm mildly concerned that we may have jumped the gun a bit, but
Yeah, okay, let's see. So this
I
should
hope
be
not.
36. This should be exactly 36. 34!
oh, nice. Okay, never mind. I lied.
You
Awesome.
know... Huh.
Oh, that's great. I guess maybe because of the maybe because of the changes in like either alignment or the fact that we moved like the branches around a bunch. Either way, awesome.
Yeah, that's pretty cool. I think I want to take a 5-minute break.
I'm going to have to take a 8-hour break. I need to go to bed. It is reasonably late, and I have work tomorrow. So, yeah.
I'm going to say 0025 ET / 925 PT. Okay. Yeah, I'll be right back, guys.
And I will take my leave.
Okay.
I'll see you later, man. Have fun.
Okay, thank you.
Yeah, no problem. Absolutely.
Well, that's weird. The little post-it note fell off. Well, I feel like I'm ready for more. I don't know, how are you guys feeling? This feels like it's been pretty good. Oh boy, Friday. Come on. I'll just cuddle with my cat for the next 3 minutes.
Go off.
Toucans, if you have a PR or something that could, if you know some way to make oh, hold on. You're a good boy. If you know some way to detect for when like labels are misaligned, that would be awesome.
Is there a good place to list the different extensions to risc-v and the instructions included in them?
I mean, the best place to handle that is right here. If you look at the ISA, it lists all of the extensions that anybody cares about. So right here, if you look in the table of contents on the left-hand side, I hope you're looking at the stream, Wilmore.
Yep.
M, A, Zicker, F, D, Q, the weird WMO thing, C, B, J, T, P, V, ZAM, STO, and like when you go up to the 64-bit stuff. What? What?
I'm trying to find I'm looking at the processor manual for this little guy.
Uh-huh.
And it says, I'm looking at the actual manual for the core.
Yes.
And it says that it has the XW subset.
XW? What is
yeah,
that?
and then it said it extends it by adding some compressed directives for some more instructions, and I can't find any of them.
Maybe they're just the logical ones that should exist, I guess? Like if we look down at, which chart is it? It's this chart here. Maybe there's just instructions that should exist that don't? Like these two reserved instructions. Oh man, wouldn't it be nice if somebody could figure out what those two instructions did? Trying to see where else are other unknowable instructions. Quadrant 2. Oh, there is a side note, Wilmore. This processor does stuff with the weird, with like the 64-bit instructions and the like the floating point instructions. Like those don't mean what you think they mean. Like they do other loady story related things. But I've never seen it documented anywhere.
Okay.
I just know that I've seen in the output from their code, there's calls to these like weird instructions.
That makes life more interesting.
Oh man, look at this instruction right here. The subset of 0, 1, 1 and 0, 1. Like, what happens if you... Oh, I see. It's load upper immediate. Never mind. I guess, yeah, what happens if you do, like, c.li with x0? Does it do something? I don't know. There's, like, a lot of things, like, undefined opcodes that I'm really curious what they do. Oh, I guess time to get back to it then. So we're 34. It would be really fun if we could maintain the clock out thing, and be able to have our loop too. That would be awesome. I don't think it is though. I feel like we've really squeezed this down as much as we realistically can. Let's see. Wait. I thought the compressed instructions couldn't access certain registers. Look at this, though.
Some don't.
Oh, but some do. How do you know which
Yep.
ones do and which ones don't?
I was looking through the manual, and there's some that have different forms.
Oh,
And
it's the
some of them-
apostrophe. Right? This apostrophe?
Some of them are allowed to access. They have 6 bits for register specification, and some only have 3. Generally, if it's a single register with an immediate, it can access anything. So, like all the immediate forms.
When you say the immediate forms. I'm looking at this here, and I see, I now know for a fact that c.add can do any register. And I also notice here it has the full 5 bits. But then I look down some, and I see here, like, SRLI only has 3 bits dedicated to it.
The CR and the CI and CSS format instructions can access all the registers. The CTW, CL, CS, and CB are limited to 8 of them.
Okay. Oh, I also see branch equals 0, branch not equal 0 are limited. Man, that would be powerful if we could get around that, but... Are load stores limited? All load stores are limited too. Darn.
The stack-based ones aren't.
Say what?
The stack-based ones are not.
Oh, yeah. That's a good point. Which one is that? That's like C...
C.LWSP, LDSP, LQSP. Well, we don't have those.
Yeah, here they are. Well, I mean, I think we have LDSP, right? No, we have... Oh, I don't remember. We have something. I know that I have seen it use compressed instructions to do stack relative loads. Anyway, let me just see what happens if I expand that out.
We would only have LWSP.
I'll be darned. I just aligned them, and now it all works. This is exactly 32 cycles now, including the blips.
Wow.
So, okay, look at how cursed this little line of code here is. I have to option no RVC around this one instruction so everything still lines up correctly. Huh, okay, I think we're cruising again. What is the next step here? Our next step is to... Oh, we have to make sure that we're also, when we store the word, that lines up too. Okay. So this should be 64, but it probably won't be, so we're going to have to do some work. It's 62. We have enough time for one more thing. Oh my gosh. Huh. We have a free cycle. Oh my gosh. Surely that we're going to find some bug in this code and we're going to be like, oh no, we have to go do something the slow way. But, oh man. I don't want to mess with it right now. And we'll have to do figure out bit. We'll have to time out the bit code, the bit stuffing code. Okay. This is a thing. This is totally a thing. I'm so surprised that we have enough. Okay, so here's the test now. Here's what we're going to do. We're going to take this, and it looks like this is, let's make sure it actually lines up. 1, 2, 3, 4, 5, 6, 7. Oh, we still have the bug. We have to go roll it back one. Let's fix that now. Oh my gosh, this is amazing. Okay. Actually, let me take a note on the time. What was it? It was like 3:30-ish. Stream 3:30-ish. Everything lined up. Okay. We need to... Oh, we still need to handle the first byte thing. I forgot what I just said. Does anybody remember what I just said? Because now I forgot what I needed to do.
The first byte thing?
Oh, yeah, thank you. Okay. The first byte thing. How are we going to handle that?
What was the issue?
Once we read the very first byte, we need to decide if we're going to be doing CRC 16 or CRC 5.
And how do we determine that?
We determine that by looking at the very first byte and hold on. If I'm looking it up right now. If it's a token packet, which means the second to least significant bit is a 1, or sorry, 0, then we do CRC 5, and if the second to most significant, least significant bit is a 1, then we do CRC 16. So how do we structure this to be able to detect that and do the appropriate thing? There's Friday. Man, I hate this. I'm losing a little bit of steam here. So we want to be able to detect that, and we want to be able to branch. We can do that here, I guess. I wish we had one extra cycle, because then we could move this up a few cycles and we would have time after the first byte. Otherwise we ran out of time, so we're down here. You know, who cares if we lose like 2 cycles after the first byte? I do. I care. I don't want to do that. Actually, how much worse is that if we move this up here? I don't want to do all of this with macros. Okay, tell you what, let's fix the bug first, and then I will worry about the first byte. We may not get that done today. It might make sense just to printf from CLand to make sure our data is correct, because it might not be. Like, we wrote all this assembly code and we haven't really tested it. So I should probably do that too. Yeah. I also just had a random thought. I wonder if there's some special polynomial you can use where somehow both the CRC16 and the CRC5 will come up with something that you can identify after the fact if it was correct or not. That's another question. Actually, let's write these things down because I'm going to forget them.
Trying to.
So the first one is figure out why we are 1 bit off. We lost first bit. Second question is how do we handle doing something different after the first byte? Next question is handle proper CRC. Third question is, can we magic the CRC so that we can do the same computation and end up with and be able to tell a correct message from a wrong one later? Okay, so let's fix the first bug first. First bug is we are not lining up right. Our very first bit has slipped. Why is our bit slipped? So when we're done the preamble, also let's turn on the debugging here. Boom, we're right here. Done preamble. We do all of this stuff. For debug. What happens if I just get rid of all the knops? Well, that's interesting. Well, that might have actually done it. Oh, I see. So what actually these knops show is it'll be right after it is when we sample the bit. So there's another phantom one over here, which we should probably show. I think I'm going to go show it. Show debug blip at beginning. Okay. Okay, so yeah, so we have the debug blip, samples here. Okay, really what we want to do though is we want to have a couple more knops in here. Okay, so we have blip, blip, sample. So sample will happen right around here. Blip, blip, sample. Sample will happen right around. Blip, blip, sample. Blip, blip, sample. Blip, blip, sample. Let's make sure we're still lining up. So I'm going to go check the timing between here and here. 32 cycles, just like it should be. Let's check the long one. Here to here. 62 cycles, like it was. So we do have the ability to do something like... Yeah, okay, so this is working now. Okay, so that fixes that. So we'll be, is it that? I guess it's that. Now we want to do something different after the first byte. Let's not do that. Let's just export this to C world and see what we get. So once we're done receiving, that's the data OK thing here. We're going to want to call some C code. And so what are we going to want to do with this? We're going to want to have void handle RV03 USB handle data, or handle packet, I guess. And it's going to be USB buffer, but we can pass that in. And actually, it's going to be uint8t is the data type. Buffer and length and maybe the CRC that we have, the check. We could check that in assembly, but well, for right now, let's include that. Okay. Let's just not worry about how this is going to break everything, and I'm going to just say printf in here. What did I do wrong? Oh. I really wish it wouldn't warn about that. That's really annoying. Uh-oh. 129. Oh, this is something is broken. Something, I thought it was working before. Does anybody in chat remember how to make... Wait, why did that just... Oh, whatever. It turns out, Wilmore, we were not actually testing the code. It was all crashed.
Oh, no.
Or it was being tested. I'm not exactly sure. Let's see if it... We're going to have to just recheck to make sure it's correct. 32. $64. Why is it 64 again? Means we don't have any extra time. I'm not worried anymore. We'll figure that out later. Whatever. we're gonna have to import the C function. The C function is rv blah 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 handle packet. Data, okay. Let's also make sure. What is data okay? Oh, data okay is just not used. Okay. Data length CRC. Let's look up RV32 calling conventions. Oh, you know what? I am blowing up X. I'm gonna blow up the X, GP, and TP. Let's save those. So 44, 48, 52. Okay, so now in here we can do anything we want. So, and we can blow away registers too, so we don't have to save anything. We don't have to worry about any of that. Looks like A0 through A whatever are the registers we're going to be using. So first of all, we can use A0, so MV A0, and we're going to want to put the pointer to our buffer in that. So there, so that's A0. The next one is the length, so we're going to have to compute the length, which is going to be sub, and we're going to take the current place inside of our buffer, which is T2. So we're going to sub, so A1 is going to be T2, and what is the, I guess it's A0. So that's going to tell us the length of bytes that we're using. And then MV A2, so CRC is, I think it's A3 if I remember right. A3 is running CRC, yeah. A3, and just for the sake of it, A4, we should probably set A4 to be a reasonable polynomial. What was the polynomials we were using? Blah, 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 blah. So we'll just assume 16-bit for now, and we'll worry about that later. Okay. Oh, make monitor. I should have guessed it. Clean all monitor. Do we get a printf? Yeah, we're not going to get a printf. No way is this going to work. Why is this not working? Let's see, do we get printfs there? Oh, I never actually called the function. Duh. Oh my gosh. I feel foolish. Ghoulie, I just noticed your message. Is GOLUI 42? Yeah, let me know about that add-I thing. And also, Alex, that's an interesting point about CRC5. You're right that the CRC5 probably doesn't matter. Though, in legacy systems, isn't it possible for there to be multiple devices on the same line that would potentially respond to it? Like, I don't think you can get away with not checking. Well, maybe it's actually not that bad. I don't know. Anyway. Yeah, we're gonna say, can I just say that? Does that work? Okay, well, first of all, we have to make sure we can print. Okay. Well, it seized up as soon as I plugged it in. Great. Hmm. Friday, stop. No. Not right now, I'm so close. Hopefully I can get the Sele to capture. Come on. I can get the Sele to capture long enough to... Good grief. Please just capture. Did I get anything? No. No. Well, something broke royally, so we are no longer getting blips. What line, Ghoulie? 42. Here, let me commit it, and then you can tell me. Oh, I don't need a semicolon there. I mean, I can add it, but... Great. What did we change? We added that. Okay, let's just not do that and see if things will explode. Interesting. So things are still exploded. Don't bite. Stop biting. Friday, come on. he's let me capture. Oh my gosh. Okay. So something is still exploded. What could have been exploded? Yeah, it would be nice if I did the CRC. That's still like, that's a problem for like future though. That's not like a let's get this thing working problem. Let's undo. Okay, does this work? Well, I'm gonna say no, it doesn't work. What did we break? Oh, is it that? Did we break that? Okay, so yeah, somehow this here, 52, why would that break things? Yeah, it definitely broke them. Okay, so I'm noticing that this code is like just totally getting hosed now. I guess I'll put everything back. I'm gonna just not worry about X3 and X4 or something. Wait, minus 44. No, minus 52. Oh, well that's probably it. I probably... Okay, X3, X4, let's give this a shot. So whenever you enter an interrupt, you have to, yeah, you're right, exactly, Toucans. So whenever you enter an interrupt, you have to, like, why am I forgetting what I'm trying to say here? You have to save all of the registries you want to be able to use, and then you can mess everything up, and then when you're done with the interrupt, you have to restore everything. Okay, so let's try this. We don't call this. Oh, weird. Hello is working now. I can totally believe that there's something cursed about calling that from inside an interrupt. I don't think we should be calling printf from inside an interrupt. Or is this just broken now? If we don't call that, what happens? It works. Or is it working? What in the world? Star star? What does star star mean? What in the world? Oh, okay, hold on. uint 32 or uint 8 t star t star buffer equals USB buffer. Zero zero C3 00 A0 C0. Let's see if that makes sense. Whew. 00 C 0 0 3 C no 00. So that's 1 1, so that's a 3 0 0 0 0 1 1. Okay, so this is reversed end, like little endian first. So this part here is the 3, then this is the C, and then it's 0 0 0 0 0 0 0 0. Then it goes 1 0 1. So that should be 1 plus 4 is 5. No. Something is wrong. C300. Something is wrong. A00C. Maybe it's just the first one it's getting. So 1011. No, that's not it. Close but no cigar here. I do want to get this working, and then I think we can end the stream. I don't know, it's only been 4 hours. It feels like it's been a lot longer. 11000011. So that's our C3. 0000. Are there maybe different messages and we're only seeing... No, B request 5. They're all going to be the same. We should print out more of these. 4, 6. C300A01C. That can't be right. One 000011 00000000 101 000000. Maybe our bits are inverted. I thought it was USB is LSB first, right? Or is it MSB
Yes.
first? Oh, I'm an idiot. Okay, let me show you the broken code. You know how we had that free time? I don't think we're going to have that free time anymore.
No.
Parallel, this is using a Sele, which is a very expensive analyzer, but there are other much cheaper analyzers with SIGROC and PulseView. And you can also use like the Chinese knockoffs of the really old ones with the Sele software, but that's not good. So yeah, there's different options, but yeah, look up Sele and look up PulseView. Those are the two things that you probably care about. That's right, that code that we have to fix. Okay, time for a new getting things started. So we shift left A2 and so the idea is like on the very first bit we put it in the least significant bit, then we shift the register 1, then we put it in the next bit, then we shift it over 1, then we put it in the next bit. So it actually ends up being MSB first instead of LSB first. So what we need to do is something that's like SLTI, but we need to set like the not least significant bit, or we need to find some way to just like flip everything around. I think that's okay. I think we can figure out something here. There's got to be something here. Ye mids, you can't use a tilde here because all that does is it makes the zeros ones and the ones zeros. Instead of flipping it this way, we need to flip it this way. Yeah. But what we could do is if we can figure out a way to write into the 7th bit and then shift down, then that's sufficient. We can do it that way too. And I think we should be able to do something like that. C.add_I. What can we do there? Oh, wrong document.
Add I would let us do anything in the lower 12 bits.
But that's and I, not C.and I.
You look at and I?
Say what?
And or add?
I was looking down below at the add, but I wonder if we replace this with oh, this is going to be cursed. So 0, 0 means 1, and 1, 1 means 0. We could just store all the bits in backwards and then flip them up here. Do we? I can't remember if we have that spare cycle or not. No, in fact, we're now negative. I think that was because we probably have a bit alignment issue here. Let's see if we fix the alignment issue, if that fixes it. Okay, good. Yeah, we actually do have a spare cycle now. That's so cursed. Is it neg? Is that what I want? That flips all of it, I think. Why not just use C.SLLI ACE07? Sorry, can you, shoot. Where did that come through? Oh, I see. Why not just use C.SLLI A07 and then shift A2 to the right instead of the left? Yeah, that's what I think I'm going to do. But one of the nice things is if I don't use SLLI, oh wait, C.SLLI A07, is that a, yeah. But it's actually even weirder because it's, because A0 is actually shifted over by USB DM. So what we probably want to do is C.S LLI, we want to shift up by... And wait, and then shift A2 to the right instead of to the left. Yeah, but that's what I want to do, but we have to shift it up. But one of the nice things about SLTI is that this also inverted the value, because otherwise we have to do the neg up here. Yeah, if we do the neg, I think it's fine. Okay. But then we're going to have to fix this code down here to not need, to want something inverted instead. Man, this is like surgery, I feel like. There's so many things that have to go right. And this will be, so USB DM is 7, so 7 minus that, that'll be 0. Okay. And then, oh, but we want to and it off. Oh, but we can't do that. Wait, can we? And I. How many bits do we have in and I? We don't have enough bits.
C.ANDI?
Yeah, C.ANDI only has 5 bits. Well, 6 bits. And what I want to do is chop off the MSB. Because otherwise we're going to have 1-1 that's going to be shifting down. And that's going to blow away stuff. How do we flip this around? Oh my gosh. Maybe you can just keep SLTI and shift it. Okay, but that's going to slow things down. So if I do this, that's going to be an extra instruction in this whole thing, and it's going to throw, we're going to be up the creek. Oh, we do want to do SLS shift right logical. I claim that this is going to throw all of our timings way off. And by way off, I mean off by 1 cycle, and then we are hosed. No! What? Why? What? What? I don't know where 4-3 is coming from, but I have no idea why that works out. I thought, didn't we just add like an extra instruction in the middle of our code? Oh, okay. Well, good. Now the other thing is slow as molasses, but the other thing being the byte end, but Duck, I really don't understand what you're suggesting here. No, toucans. The long one is now 68. Which makes no sense, because this happened after that. I don't know. I don't know how any of this works anymore. wonder if we do this whole thing out of order. Like, what if we do the bit stuff check first? Maybe that's an avenue. We do the bit stuff check first, and then I think we don't need to do that. I'm sorry, Duck. I don't know what you're saying. Duck is trying to talk in a different channel than the YouTube channel. I don't really know why. Oh wait, I just noticed something. We could detect the single-ended 0 skip out here. Well, no, that's dangerous. Duck, I know if I have a temporary value we can do this, but we have no temporary variables. I know we can feed bits in from the left. That's what I want to do. But I need to find some good way of getting a 1 in the 7th bit for this in order to shift them down.
What does it need to be in?
So I need to be able. So right now there's a 1 bit in there's a 1 bit in both the DM and DP bits, and those are like 3 and 4 over right now. And what I need to do is I need to get those in the 7th bit, so that I can OR it with the thing as I'm feeding it down. Yeah. Actually, it's even weirder. What's actually in them is 1 1 if it's a 0. And 0 if it's a 1, or 0 0 if it's a 1. Okay, Duck says that won't work either. Well, you don't hear anything? I think my sound is working, Electronics Boy. Let me know if can anybody else in chat tell me if sound's okay?
Yeah. What? Yeah, you're okay.
Okay. Duck, I'm okay with switching the 0 and 1 for A0 everywhere. I don't mind doing that, but I don't even have a plan for how we can make this work. I'm having a really hard time with doing this. So in here, Okay, so this is what I have. In this case, A0 is 00110000 if it's a 0 bit, and 00000000 if it's a 1 bit. Friday. Anyway, I have to then, what I need to do, A0 needs to be 10000 1000 0 if 1 bit. You okay, Friday?
So can't we just shift it left 3 bits?
Well, if we do, it's gonna go out the end. It's gonna be A0 will be 11000 000 1 2 3 4 1 2 3, yeah, which that won't work because then if we OR it and we're shifting down to A2, then that's gonna poison it because we're gonna have 2 bits out there, and we can't just AND that because there's no C.AND for that. I guess we could AND this off, and then we have a weird restriction where you can never put USB on the top, on either of the 2 top pins of any register, which seems really silly, but maybe that might be all right. I mean, sure, let's give it a shot. So this is going to be flipping all of the bitwise stuff. So this is going to make it, A0 is now the wrong thing. Which is fine for here, but not fine for down here. Well, let's at least, Okay, Duck says they have an idea. Man, I feel bad for you guys. We're gonna go spend like an hour of this live stream just trying to shove some bits around after all of this because of some little teeny bug. Duck, tell me your idea. If or if we could somehow convert 0 to 0 and 100000 to the number 7, we would be set. Is there any way of converting 0 to 0 and this jazz to 7? We could do the opposite. Oh, we can't do it with add I. Electronics boy, I wrote the USB stack for the ESP8266. You can't just use that stack here. The other thing is I'm trying to make all of this fit into a 1920 byte boot sector, so that when you power on the chip, you can then like be able to flash the ESP over USB just like an Arduino, and be able to like erase the whole thing except for the boot area, and be able to basically have like a bootloader that's USB aware. That's my goal. Duck says, worst case we can shift A0 back. I mean, like, sure, I can push A0 back. That's fine, but that still doesn't give me what I need. The only thing I am looking at here, though, is this is pretty close to what I want. Like, A0 out of here. Maybe the right answer is we try to get this all set up the way that we want. That might work. If we do our CRC stuff first, then A0 is already very close to the right answer. And then if we do this stuff before the CRC, it might work out. So then the question would be, if we did that, if we went with that approach, how do we go from this to 7? Or what if it was 6? Could we do it with 6? Sub I6. I think we could do it with 6. I think we could do this. Oh, this is cursed. This is tastily cursed. Okay, so here's my thinking. In here, if it's this, then oops, this is a 0 bit, otherwise it's a 1 bit. What we could actually do is I'm gonna have another pound define here. Pound define shift data into S2. Or is it A2? A2. And what we're gonna do here is question mark, question mark, question mark for what we're gonna get in. But then we're gonna just say C.or A2 A0. We should document what A0 is here. Oh no, we're abusing the fact that A0 is this cursed thing here. Oh no. Okay. Let's see if we can get the first two, then we'll worry about the last one. Okay. And for all I know, maybe if we only have the 0th bit set, that's that might be a reasonable thing for our XOR algorithm. Let's see. Do we have an XOR algorithm where that's how we operate? So what I'm trying to do is I'm trying to think if I have A0 in the form that I would have it going in, can I do what I need to do? So which registers? Brabkistan? Oh, you mean like name A0 what A0 is and S2 what or A2 what A2 is? Yeah, I might do that. Not right now. Well, do I? Because A0 is just complicated, but the others maybe. Anyway. So here, what we're going to do, I don't even know why we did it this way. Let's undo that. So we're going to shift right logical A0, and what we want to do is shift it so this is down here. So we're going to go shift it right by USB DM if 0 will be -1. If it's 0, it will be if 0, it will be 110. I do that up there for A0 S0. Ah, that won't work. This really does need to be 111. Because otherwise, if S0's lowest bit is set, then it will be unstable. So no, that won't work. If only this was one more bit. If this was one more bit wide. So what happens if I just do something silly? -1 0 0 0 0. Uh-oh. Friday is complaining on the porch. Friday. Friday. Okay. I am just going in circles at this point. I feel like I might need to sleep on this. It's so
Seems
nonlinear.
reasonable.
I feel like this has got it. This is like so close because we have the data, which is this. We will need it in the form of. Oh, we need it in the following forms. And it'll be, and we can do this in basically any orders, but as long as we have some way of getting from one to the next. 0 will be 1, 1, 1, so 0, 0, 0. And then 1 is 0, 0, 0, 0 for, what do you call this? For the bit filling, bit, what was the term again? Bit stuffing. We need it in 0 is for writing the data out, and we need it in the form of well, I guess we could do a lot of things with the XORing, but or is it? We could probably fix that up later because we could just not everything. And then for the XORs, it's either 1, 1, 1 or 0, 0, 0. Or flip for the CRC. So yeah, okay, I think that's what's going to happen. I think we're going to stop it here. The idea, though, that we're going to need is we have the incoming data, A0, and it starts off in this. This is what A0 is. 0, 0, 1, 1, 0, 0, 0, 0, and then or 0, 0, 0 if it's a 1-bit. We need it in the following way, which is 0, 1, 1, 1, or 0 for bit stuffing. And we can, and we also need it in this form for the writing the data out. And we need it in this form for the CRC. So we have to find some way of getting from this to each of these. And we have some other like leeway. Like this actually can be a little bit different. This can also be like or flipped for the CRC, or flip bit. No, flip top bottom. Yeah, I think that this is kind of along the lines of what we can do. Yeah, we could also, I guess, even do something really cursed, like this could also not just be flipped but negated, and then we could use like an and or an and on the thing. So for writing the data out, flip top bottom, or inverted. Adrian, I am the king of LUTs. I'd like to believe I am, and this is not the place for LUTs because we need to keep our code very, very, very small. Yes, no, if we did a lookup table, this would all be done. This is all very easy to do with lookup table, but I want to avoid the lookup table, so here we are. Unless you mean, oh wait, do you mean like lookup table as in It would just be too slow to read. It would be no, it's too unreliable. We can't use lookup tables here. I see what you're saying though, because like, oh, if it's a 1, read what all the values are supposed to be from this side. And if it's a 0, read what all the values are supposed to be from this side, and then you get your answer. Like, yeah, that makes a lot of sense. That's fair. But no, we really should try to do this with the risc-v assembly. So I think that's where I'm going to leave it for tonight. Thank you everybody for coming out. I'm going to go do this homework offline, and I'm going to go try to come up with an answer. And then hopefully next time we stream, we'll be able to start getting some of those packets in C-land. And then we'll be able to respond to them, and we'll be able to enumerate as a device. So next time, it's probably not going to be a fully enumerating device, but we'll at least play with a lot of the data. So yeah, thank you everybody for coming out today. It's been a pretty steady stream, 34 plus people. If anybody has any other questions right now, please feel free to let me know, or we can chat about it on the Discord server. I'll hang out for another minute or two here, but I think this is where I'm going to leave it, because this is definitely something I want to sleep on, because I feel like this has got to be something that is solvable. Thank you for coming out, Wilmore. This has got to be late for you.
Yeah, come up on 2 a.m.
Oof.
6:30 is gonna look ugly.
Oh no. Oh no. Well, thank you for
That's every
coming
morning
out
for me.
Nonetheless, yeah, it was a lot of fun. Probably won't be able to stream again until Monday of this coming week, though. But yeah, no, I think I'll be able to stream, and then who knows? Maybe weekend after this coming one, we'll actually have a USB stack on the CH32V003. I don't really see much else going on in the chat. So yeah, I'm gonna just end it here. Thank you very much, everyone. Bye.
Good night, everyone.